Good afternoon, everyone, and welcome to the Zero Carbon Future Pavilion powered by Clean Air Task Force. Thank you very much for joining us. Before we begin, I'll just draw your attention to the QR codes on the side, so if you do require live translation or transcription, please do use those. My name is Rebecca Tremain, and I'm Head of UK Government Affairs at Clean Air Task Force, and I'm joined today by a really great expert panel for this conversation on hydrogen. So I will just introduce them. We have Gus Wakim. He is Hydrogen Technology Director at Clean Air Task Force. We have Dr. Peter Schniering, who's the founder and CEO of Future Cleantech Architects. And we have Emanuele Bianco, who's Program Officer at IRENA. And lastly, Oliver Phillips, who's Regional Head of Sustainable Finance for the Middle East and Africa at Barclays. So hydrogen is increasingly seen as an option for decarbonising certain emission sources, where direct electrification or other low-carbon solutions aren't technically or economically feasible. And we've seen a lot of conversation about hydrogen at this COP. We've had the International Organisation for Standardisation presenting a set of new clean hydrogen standards. And we've also had a number of countries signing up, launching a declaration of intent on clean hydrogen so that they can work towards mutual recognition of certification schemes to help facilitate a global market. So there's a lot going on, but this isn't really the first time that we've looked to hydrogen as a solution. It's actually the third time in 50 years that we've tried to utilize hydrogen at scale. So the question we're asking today, is it something that's different? This interest can be traced back to the 1970s, but basically previous attempts to make this potential energy carrier most recently in the early 2000s haven't succeeded in establishing hydrogen as an alternative to conventional fossil fuels. So there are some that are arguing that this time is different because hydrogen isn't being seen, it's not being considered really in terms of energy security, although in the recent years, obviously that's become more important, but more as a low carbon alternative. And in some cases, there are differences. We've got a scale up of renewable energy production, and this has enabled costs, and wind and solar power have given new life to the concept of producing hydrogen from renewable electricity. So there are some things that have changed, but what hasn't changed are the physical and chemical properties of hydrogen, including the fact that it has low volumetric energy density, which makes it incredibly difficult to store and to transport. So this has historically made it very difficult for hydrogen to move beyond industrial processes that it's been traditionally used for. So is this time different? Is hydrogen just the hype? And these are the types of questions that we're going to be asking today. So Gus, I'm going to turn to you first. Could you please tell us a bit more about why we're considering hydrogen, the use of hydrogen today as a climate solution?
Yes. Good afternoon, everybody. Yes, so today hydrogen, as Rebecca mentioned, 99% of the use is in an industrial setting. It's used for ammonia production, methanol production, refining, and for steel manufacturing. And one thing to keep in mind before we look at hydrogen as a potential climate solution is that there are around the production of hydrogen today is responsible for around 1.5 to 2% of global emissions. And the emissions, which account for almost 830 million tons of CO2 per year, are on par with the emissions from the aviation sector. So while there's a lot of focus on decarbonizing other sectors such as aviation, hydrogen, first and foremost, needs to be taken a look at as a source of greenhouse gas emissions, its production. And so logically, the first thing in order to priority would be to decarbonize existing hydrogen production in the chemicals and industrial sector. So from a decarbonization point of view, why it's being looked at is because certain sectors cannot do without hydrogen, such as, for example, refining ammonia, methanol. It's a chemical feedstock, and you can't really electrify refining or electrify ammonia production. It's a chemical product. So, but more so beyond its use as a chemical feedstock, the methods where it's looked at to use as a decarbonization pathway or tool is as a fuel, so in power generation, transportation applications. However, as Rebecca mentioned, because of its inherent physical properties, that has really precluded hydrogen going beyond the industrial setting. It's used in an industrial setting. It's hard to transport. It has a boiling temperature of minus 253 degrees. Emanuele will talk more about the export pathways. But one thing to realize is, compared to 1970s, 2000, nothing really changed in terms of the physical and chemical properties of hydrogen, and that's what really determines, ultimately the economic effectiveness of using it as a climate solution. Thank you.
Thanks, Gus. I think that's a really helpful introduction to this. I wanted to dive a bit deeper into what you were saying about economics. So we've seen that policymakers are building out infrastructure, assuming that production is going to be $1 per kilogram. So could you just say a bit more about the numbers and how production costs of low-carbon hydrogen compare to the existing costs of unabated sources?
Sure. Yes. So today, the vast majority of hydrogen production is produced using unabated natural gas, and of course that's dependent on the price of natural gas. But generally, it could be produced $1 to $2 or $1.5 per kilogram. The production of hydrogen that Rebecca mentioned, that there are various forecasts of producing hydrogen from renewable electricity or low carbon electricity. Today, it's largely a function of the cost of electricity. But today it's on the order of $4 to $5 to $6 per kilogram, and there are forecasts that take a look at its production going all the way to $1 or less than $1 by 2050. In our opinion, that's a bit misguided, that thinking, and we actually CATF we just published a paper on the limits to the cost declines of hydrogen, and we see at least for the foreseeable future, 10, 15 years on average, it's really hard to go below $3 per kilogram. For instance, if you want to talk about the $1 per kilogram, which is the kind of the target that that's being looked at from a policy point of view for the infrastructure build out. That would require something like electricity at $20 per megawatt hour around the clock, and the electrolysis facility cost at $100 per kilowatt. So to put that in comparison, the green hydrogen facilities being built today, it's around $2,000, $2,500 per kilowatt. So we're talking more than 95% cost declines. We're not going to go into detail why that's really not very feasible, but going 95% for green electrolysis facility is not really, there's no realistic pathway. So that's why we think, $3 per kilogram on average is going to be kind of the lower limit for production at the plant gate. Yeah.
Thank you. I'm going to turn to Peter now. So as we've said, we're hearing a lot about the use of hydrogen across a range of different sectors. And I think Germany, a good example, they're keen on using it for decarbonising industry, decarbonising power generation, and also transportation applications. So I just wanted to hear what you thought, especially based on the economics and the emissions and the climate impacts that Gus has just set out, which sectors does it actually make sense to be using hydrogen?
Thank you, Rebecca, and thank you for having us. I couldn't agree more with what you and also Gus just pointed out. I think we can't change, or it's hard to change the amount, the number of kilowatt hours we need to produce a kilogram of hydrogen, basically. And we always use this example, even if you find it written off at the side of the road, your electrolyzer, it will still be almost impossible to reach this level coming to the economics. So what are the applications we need to focus on? There's several perspectives on this. I think first of all, it's the industrial processes, as Gus has pointed out. There's this massive amount of existing hydrogen, gray or black hydrogen right now, that needs to be decarbonized. And so it's industry processes. We've heard about fertilizer productions. We've heard about other productions. There's future applications where we will need it, such as steel. Actually, I gave the example some weeks ago at another occasion. Michael Liebreich mentioned in the Netherlands at a hydrogen event some weeks ago that steel is the only no-regret application actually for green hydrogen if you think of the marginal value of a megawatt hour of electricity. If we don't use it on steel, it's always invested better elsewhere to directly electrify to have a positive climate impact. And so, but going along these applications, because that's what you asked for, so it's certainly steel with the direct reduction route. It needs to be the existing applications of grey hydrogen that will need to be decarbonized. And then there's a few other, but there's, unfortunately, and we see this in Germany a lot, in Europe a lot, there's a whole lot of regret applications that we shouldn't go into because they're way better decarbonized without hydrogen.
That was actually going to be my next question. So which sectors shouldn't we be using it?
You can already sense it's driving me up the wall, okay, the discussion in Germany. So, of course, we should not go into things like domestic heating. Don't use hydrogen for domestic heating. You're all nodding probably, but this is being discussed. Power generation, in most applications, no application for hydrogen. Of course, on the ground transport, especially light vehicle transport, cars, it just doesn't make sense. It's so inefficient, it's so expensive. Hydrogen will be scarce for decades to come. It will be expensive. Let's focus all the resources on where we can really use it. Gus has pointed that out so well. So yeah, there's a lot of things to stay out. You know the hydrogen ladder, obviously, also Liebreich and all the other guys contributing to it, all the other experts. So, but in particular, looking at the debate in Europe, I would say, stay out of ground transport, stay out of any metro type of transport. Even trains, you know, we had the discussion last year with maybe if I still have that minute. So I was invited to speak at a panel of the German State's Ministry of Transport, and I was the first to be asked a question. And before they asked the question, they played it like this advertisement movie for a town in Germany that's building up infrastructure for hydrogen buses. And the moderator, who wasn't from the climate or tech sphere, showed the movie and turned to me first and said, "Hey, Peter, so why has hydrogen such a great future in transportation?" And I said, "I'm so sorry, everybody, but it doesn't. It's the worst thing you can do. And this town will regret it. And they'll go to electric buses because it doesn't make sense." So they keep discussing these things all the time. No domestic heating, no power generation. Let's focus on what's relevant. Sorry for the long answer.
No, that was really helpful. Thank you very much. So Emanuele, I'm going to turn to you now, because there's been a lot of discussion as well about the emergence of global hydrogen trade. And I referenced that there's the agreement on the standardization and the mutual recognition that they're talking about at COP through that declaration. So I've also said that hydrogen is really difficult to transport, and all the consumption is usually taking place at the site of production. So I know that at IRENA you see an alternative scenario playing out in terms of hydrogen product trade, and I wondered if you could speak a bit more about that and talk about why hydrogen is challenging to transport. How can hydrogen product trade be a viable alternative to trying to transport only the molecule?
Thank you. Thank you for inviting me. I'm loving this conversation because it's really time that we acknowledge the new stage of discussion about hydrogen. You started the discussion saying something very nice, like hydrogen is increasingly recognized as a way to decarbonize pieces of the energy sector that cannot be electrified. And this is why this time is different. In the past, every time we look at hydrogen for decarbonizing cars. That is something we can electrify. So if we're looking at something different, all the hydrogen sector will be looking different. We have to imagine a world that is pretty much different. Now, we can also take advantage of knowledge of the past. The energy industrial sector always have been a strict relationship. And the story has always been the same. Where there is a source of energy that is cheap but difficult to transport, there the industry moves. When coal mines were opened in the UK in the 19th century, steel makers didn't try to move coal. Coal is lumpy and difficult to move. Instead, they moved the steel mills near to the coal mines, and they created the big cities in the UK. Now we are seeing, we having the most difficult energy carrier to transport in the world. Literally, it's the most difficult energy carrier to transport, and we are thinking to take it, liquefying, converting it to ammonia, then putting it into a ship, moving 4 kilometers, hoping that we are managing to have the technology. We bring it to Rotterdam. In Rotterdam, there will be an ammonia cracker that will make hydrogen again and then goes to a bus in London. I think there are better options. I mean, anyone that has an energy engineering degree or studied energy is having hitches at thinking about how much the efficiency is going to be low in this case. Instead, we have this great opportunity to have developing countries that are rich in energy, that are rich in sun and wind energy, that are willing to invest for industrialization because they are lacking of it, and they are thinking more and more. There is a realization that hydrogen trade is going to be difficult, but ammonia trading but also iron ore briquettes trading is going to be much easier. And it's not unheard of to, as I say, the moving industry where energy is cheaper. And it also goes against the good old extractivist and colonialist way of thinking. Oh, you're resource rich, you don't have industry. bring your resource to me, that I have the industry that can consume your resources here in Germany, in Italy, in Europe, Japan, or whatnot. And the things are changing. The waves is changing because when a country first wrote about hydrogen strategy for export, Chile, in 2020, they read the German strategy and they said they want to import hydrogen. We have the resources. We can export it. 25 gigawatt by 2030. Now, of course, this seems a bit overstretched now after 3 years. But many other countries started doing the same. They saw someone wants to buy, so I can sell it. And then there was a thinking, well, a lot of countries can sell hydrogen. There's Namibia, all Latin America, all South Africa, all the GCC, Australia, and there are few countries that can buy it. It's an oligopsony. It's not anymore an oligopoly. They are not going to become the Seven Sisters or the OPEC of hydrogen. It's not possible. Hydrogen will not be cartelized. And again, the power of trade, the power of deciding the winners will be in the global north. So countries are starting to thinking about changing this approach. And we have a clear example here in the UAE. The UAE was saying we are going to export 25% of all the hydrogen traded in the world. Then they wrote a strategy. And if you read the strategy, what is written, we are going to decarbonize our own industry first. We are going to attract industry here because we have the best resources. We have a good financial sector. We can take this advantage and sell green steel in Europe. That, by the way, established the CBAM. The CBAM is what is an import tariff. An import tariff that says if you are not producing steel with green hydrogen, because it's the only option you have to have green steel, your steel will cost more in Europe. Oh, by the way, I also want to buy your green hydrogen. So countries are looking at it and thinking, look, this is not going to happen. Hydrogen trade is not an opportunity if then my own products cannot be sold in Europe. And you can see, for example, Kenya wrote a strategy with the assistance of GIZ saying we are going to use hydrogen for food security, for local fertilizer production for our own country. Now, supporting industrialization of developing countries is hard, if not harder than transport hydrogen. But it's the benefit that this can bring is much, much higher. It's a assistance for global South countries, an opportunity for global South countries that we should not look away. World Bank, UNIDO, IRENA, we are supporting this vision. We are working on it. Tomorrow we are launching a report that look exactly on this topic for industrialization of developing countries using hydrogen and as a pool to attract industrialization. And I really believe this will be the discussion that we're going to have once we get real with hydrogen.
Thank you. I actually wanted to touch a bit more on, sorry, I'm going to come with a follow-up. On the report that you're launching tomorrow, are you able to say anything more about the findings beyond what you've just said?
Of course. So more than the findings and the insights, because the idea here was, again, to get real about industrialization. And basically, we found ourselves with UNIDO and IDOS that we were looking at hydrogen. We noticed that the drivers, the ideas were changing, and we needed to record it. We needed to share these insights, to share these ideas, and show that the world of hydrogen, the world of industrialization, the world of industrial policies is changing. And yes, one insight I can share now is that, well, industrial policies are back. Industrial policies were considered as something to be shared in a way, an ineffective way to govern a country, an ineffective way to drive the industry and the free market would solve every problem they have to the sheer power of free market and efficiency. Now, since we have seen that this is not happening, many countries, in particular driven by the desire to have shorter supply chains, after COVID, after the Suez Canal impact, after the natural gas prices spikes, they started shortening the supply chains. And they started shortening the supply chains, acknowledging the need for decarbonization. And now we are seeing at least 3 different ways to do industrial policies. We are seeing the European system, protectionism with the CBAM, with some support for nascent industries, for example, the green hydrogen industries. We are seeing the global South countries doing what we can call de-risking developmentism. This is a situation where the global south countries do not have a lot of money to invest in green hydrogen, but what they can do is to de-risk the investment as much as they can so that the investors are willing to come, maybe supported by some international finance vehicle, so to invest in the country. Namibia, Chile, they are clear examples where developers and the governments are really talking to each other on a daily basis, so to make sure that there are no barriers to achieve the development of this project. And then there is the GCC example, where you have both a global south perspective, but also the money to invest. So they are both looking at the risking investments and also to support local consumption. And I was today in an event on hydrogen in the GCC, and there what I listened was something that honestly a few years ago would not be normal to listen. We are going to give support to these projects, but only if they can bring some benefits locally. And this is what industrial policies are about. And they are back. They are back for the decarbonization. They are back because of many reasons, but they are back everywhere in the world. And maybe the discussion should move from the energy sector, where, for example, I'm from, to the industrial sector.
Thank you very much. That was really interesting. So we've already started talking about finance, Oliver. So I'm going to come to you now just to get a bit more of your insights on this area. So we know hydrogen projects are really capital intensive. I think if we take the example of NEOM, the estimate I think is $8.4 billion US, 6.1 billion of this of debt was raised by 23 different banks. And I've heard you speak in the past about what you referred to as the dunes of doom. So I'd be great if you could explain a bit more about what this means and its implications on the financing for hydrogen.
I see you very tactically left the banker for last, before everyone's interested, before you all start running out. I can't take any credit for the Dunes of Doom, unfortunately, and in fact, I don't actually know who I stole it from. But for those of you a bit familiar with sort of technology fundraising more broadly, you might have heard of the Valley of Death. And it's effectively this concept where very early stage financing, you've got lots of capital, and then you have a lot on the sort of more institutional bit, and there's nothing in between. You're sort of typically a kind of Series B type raises. With climate technology, and you know, we talk a lot about climate technology, and I think one of the things we've been talking about at Barclays this week is we should be calling it climate infrastructure, frankly, because calling it technology doesn't really capture a lot of the challenge and what companies are actually doing. But with climate technology, you almost have this sort of concept where you don't have as much capital, so you don't have those peaks of the valley to start off with, which is your first issue, and you sort of have this concept where you keep needing. You keep sort of going constantly until you run out of space. But you know, there's always these dips, these peaks and troughs, a bit like a dune. And obviously, being in the desert at the moment, it's great to be able to use that analogy. But effectively, it's this issue that when you're starting up in most climate technology companies, and hydrogen, I think, is a good example of this, whether you are in the electrolyzer space, when you're a project developer, and whatever size of project you're looking to develop, you need a lot of capital. When you want to build an app, you don't need much capital. You just need a good idea and some server space. When you want to build a factory to manufacture electrolyzers, you need a lot of money. And it takes a lot of time for that money to be deployed as well. So you don't see as much of sort of this early stage capital that's ready to go in, and there's a real gap in that sort of scale up phase, because you've got this issue where it's too infrastructure for your tech investors who just don't know how to get comfortable with this in the slightest. And it's not really infrastructure enough. It's a bit too tech, and there's sort of too much technology risk for your infrastructure investors. So you're very much in the middle with sort of nowhere really to go. And it's a key challenge that we find all of the companies that we're speaking to are grappling with.
Thank you. So as a follow-up to that then, what do companies need to secure investment in that missing middle part?
So I think it's the first thing is you need to be very surgical, frankly, around how you're going about your fundraising and really thinking about how do I do this in the most efficient way. You cannot follow the playbook of tech. You can't go, right, well, so-and-so did this and they went to Silicon Valley and then everyone got their checkbook out. It's just not going to happen. You need to start thinking about how you leverage more strategic investors in a stronger way. Thinking about, well, who can we partner with? Who are going to be those customers that actually want to use our technology? How can we bring them in, help make sure we're creating something that is valuable to them? And the one sort of promising thing is we are starting to see more money flowing into this space and people setting up dedicated funds. So Barclays ourselves, shameless plug, we've created something called our Sustainable Impact Capital proposition. So this is a commitment that by the end of 2027 we'll invest £500 million into climate technology companies. So it's across a whole broad range of things. In the hydrogen space, we've invested in a couple. One of them very much sort of what we've been talking about, a company called Protium. They're looking at effectively hydrogen as a service. So how do you work with someone to say, okay, this is your decarbonization goal. How do we put hydrogen in here? And how do we then create a dedicated bespoke solution for you in terms of that whole sort of ecosystem of getting you that green hydrogen? Second one called GeoPura. Now, Peter, you said power generation, not good for hydrogen. I would agree for utility scale. What GeoPura is doing is they're tackling diesel generators. And they're tackling really diesel generators in places and in situations where you can't do sort of off-grid renewables. So, for example, festivals. If you put a solar park, a small one, next to a festival site, if that festival site is used once a year, which most festival sites are, it's terrible. It's so inefficient. If you can put a shipping container unit on the back of a lorry and you can drive that around to different sites and you can have hydrogen electricity or hydrogen powered electricity being generated through it, it's great. GeoPura has now become the largest producer of green hydrogen in the UK and the largest consumer of green hydrogen in the UK because they couldn't find anyone to produce it for them, so they said we'll tackle that bit as well. And then the third example that I like to sort of reference is deliberately to rebuff some of the comments around transportation, and that's a company called Zero Avia, which is looking at hydrogen electric fuel cells for aviation. Now, this is not going to be necessarily the best solution for long-haul transatlantic flights. But if you look at somewhere like Africa, where a lot of the flights are actually within the same country or, a very short distance and are not, an A380, which has however many hundreds of people, but it's a small jet that has, propeller jet typically, that has 80 people on, that's something that can be quite a valuable sort of option. So, companies, and all three of these companies, when they've been raising, and they're all sort of in that similar kind of Series B, Series C stage at the moment, really thinking about, well, how do we be very surgical in what we're doing and make sure we're going to the right areas to raise those funds is crucial.
Thank you. So I just want to come back to what it's also related to finance, and others may want to come in. I want to go back to what Emanuele was saying about how do we ensure that this is fair and equitable so that emerging economies are also able to invest in developing their hydrogen sources. So I don't know if you have thoughts on that from the private sector perspective or if others have thoughts that they want to come in on.
I can do. Looking from a sort of EM focus more broadly, the challenge is that at the moment it's just very hard to raise funds in EM for whatever you're doing, whether it's sustainable, unsustainable, or anything in between. If you look at, Africa, for example, the fact that sort of government bonds are trading where they are, and there's concerns about debt distress, it just means that your cost of funds, it just shoots through the roof because people take the government rate and then they apply a risk premium on top of that, and that risk premium has also increased, which is obviously making things even harder. But I think it really comes down to that policy framework and what Emanuele was talking about. And if you are looking to invest in a green hydrogen project in in Namibia, for example, you have a very good idea about what the government is trying to do with its green hydrogen industry within Namibia. And a lot of that confidence will filter down, and you can go to your credit teams and you can say, right, this is how the government's looking at it, this is the ecosystem, this is the market opportunity, all the rest of it. If you're looking at a different country that doesn't have that, the pressure gets put on so much more to the project developer to justify a lot of these things, and there will be gaps. So I think, thinking about how we can make sure that, and IRENA doing great work around this, make sure that those strong policy frameworks are in place, will counteract some of this. But we've got a macro situation that is unfavorable towards investing in EM, and until that resolves, we are running against a brick wall quite a bit of the time.
Emanuele, sorry, go ahead.
Thank you, by the way. Just to include some additional thoughts. Now, as I mentioned, green hydrogen strategies have been written, in particular in developing countries, with the idea this is the market, this will be looking like. And the fact that MOUs are being signed to import hydrogen, to import ammonia, makes the strategy looking like that. And as was mentioned, a policy must be credible, and investors will notice if a policy is credible, if our market is credible. Nowadays, since we are getting real with hydrogen, probably there is also a need from global north countries to acknowledge that hydrogen trade is going to take time. It's going to be minimal compared to the opportunity for local decarbonization. But this is not only for the global north to say, okay, hydrogen trade will happen in 2040. It's more complex than this, because it means the global north to accept that is local manufacturing may move away. There is a lot of talks about being against carbon leakage. Of course, everyone is against that. But there is not a lot of talks and discussion about the fact that many countries are against the green leakage as well. So to the allocation of their own industries where hydrogen and renewable electricity are better, just better. And it's important to start talking about it, to assess what is the real impact on an economy for a greenfield investment, for a brownfield investment, or for relocation of industry in developing countries. For example, if you ask ThyssenKrupp or any steelmakers, are you going to relocate? They will tell you no. A straightforward no. Green steel is not moving away, is not relocating, because steelmakers need the client intimacy. The Swedish steelmakers want to be close to Saab. The German ones near to Volkswagen, and so on and so forth. They will not move away and increase the supply chain length toward their clients. But there are pieces of the supply chain that can be moved. They can actually improve their feedstock certainty by investing in Chile, in Namibia, in South Africa, in Australia, to produce hot iron briquettes in these countries and import those ready to be imported in electric arc furnaces and produce steel still locally. Now, we need to understand what is the impact in the job market, what is the impact in the economy for these maps. But if these companies are going to be left free to do these activities, they're going to look at this direction. And it's not going to be against the CBAM, it's not going to be against any industrial policy. The only risk is actually that they're not going to have political and financial support, because the projects are about exporting hydrogen and not exporting iron briquettes. So this is the discussion that needs to be taken in the global north too, to understand that a changing in trade perspective means a change in discussion regarding industrial policies.
Peter, do you want to come in on that?
Yeah, actually, I think these are very good comments, because if you zoom out a little bit and look at this, what Emanuele just also said, with a little more, abstracting from it. As both of you pointed out, there is no free market for this. It's all distorted, subsidized. There was something we could call a hype recently over the past couple of years. And so Oliver said, it's supposed to be one could call it climate infrastructure. So these things are so capital intensive, so long lasting in their investments, and a number of governments, regional authorities, whoever took the decisions on projects that are to be launched, don't have the full, maybe didn't have the privilege of being advised by CATF or so on some of their decisions. And so some of these things are distorted, but let's face it, these things go over so many decades and will need to be written off and used over so many decades. Some of them will be failures, and a lot of money will not be well invested on this. So while you say, Emanuele, which is completely right, these companies don't want to move, on the other hand, these processes can't be subsidized forever. And at some point, and that's like the title you're using for this event, we need to get real about this, because even if there's massive subsidies flowing into this, at some point these companies will have to meet global competition. And if it's more competitive, producing with the hydrogen, or producing whatever you are producing close to where the hydrogen is being produced most competitively, that's where the business is going to be made in the very long term, to mid to very long term. And here I think that's one of the key challenges, because any of these projects are starting with huge subsidies. Take the steel production processes. You've mentioned 2 examples. We see it the same way at Future Cleantech Architects. And so it's any advisory, advocacy hour spent before the decision is taken is so well invested, especially also when looking at, and I've seen this on your agenda, and looking at the long-term realistic potential of transporting, exporting, importing hydrogen over long distances, given all the conversion losses we will have. This is pure physics again. It hasn't changed between the 1960s, and it will not change until the 2050s. And, you know, every euro or dollar or whatever currency, we can only invest in one, even if there's a lot of R&D funding and a lot of infrastructure funding flooding the markets right now for good reason. We need to be very cautious about them, because the challenge is huge, and yeah, some of these plans give us at least massive headaches.
I think, yeah, very interesting point. I want to pick up on that with Gus. So I know a lot of what you've been trying to do is sort of dispel some of the myths and show where it should actually be used. How do you think we can inform governments in the right way to make sure they're actually prioritizing hydrogen's use in the right sectors?
Yeah, that's a very tough question. I'm just going to pick up, you mentioned NEOM, and then we talked about financing and infrastructure. Just to put things in perspective, the nature of the capital spending on these renewable hydrogen projects is very front-loaded. So let's say, take the example of NEOM. It's producing around 222,000 tons of hydrogen per year, right? And it costs $8.4 billion. If you wanted to produce the same amount of hydrogen, let's say using existing steam methane reforming, so from natural gas, the upfront capital somewhere around $450 to $500 million. Now, obviously, one's low carbon electricity, and the other's has carbon emissions. But it's suffice to say, the difference between 8.4 billion and 450 million is quite significant. Said otherwise, for low carbon hydrogen, renewable, let's say, or otherwise, you're talking about an upfront capital investment of 15 to 20 times that of the way you're generating hydrogen today. The vast majority of the discussion is always around, okay, what is the dollar per kilogram of hydrogen, which is amazing, which is great, because at the end of the day, that's what matters. But what also can matter even further is how much do I need to spend upfront to realize that, to produce that first kilogram of hydrogen, so to speak. And that, I don't think that gets enough focus, enough attention. Just, it's not just the dollars per kilogram, whether it's just there's a premium, 40% or 100% premium. It's just, what is the, if you want, the upfront capital investment premium that's going to be required for low carbon versus unabated? That I think needs to be talked about. And in terms of advising governments, there are a lot of companies out there, some with good business models, some with not, and that say, oh, we need government subsidies, government help to get the ball rolling, which is fine. But I think the danger here is that you're going to get hooked on government subsidies or taxpayer funding, not only to get the ball rolling, but to keep the ball rolling. And that's what's dangerous. It should be, you should get over a certain hump or whatever and let the ball roll. But if you're asking for subsidies or public money or taxpayer funds, which is not unlimited. You know, we don't live in a modern monetary theory system, as we've seen in the past 2 years. You know, you need to be very selective. And when you're very selective, and when you need to be very careful of how you're targeting the public money, whether it's subsidies on the production side or on the commodity side. If you really target and you're really heavy on the production side, then you start to get a lot of projects that don't make a lot of sense. So how do you advise government? As others talked about on this panel, industrial policy. Yes, I know there are a lot of very ardent free market proponents, which I am one of, but at the same time, when we're talking about climate change, when we're talking about reducing greenhouse gas emissions, when we're talking about something at the scale of society's infrastructure, no, there needs to be industrial policy. The funds where they're going need to be very targeted, and there needs to be a bit of guidance, so to speak. It just can't be a free-for-all.
Thank you. So I'm going to follow up on that along a similar theme, lightning round, so short answers, please. I'm going to do, if you've got one message that you wanted to give to either policymakers or to financiers, what would you want to encourage them as an urgent next step to begin scaling realistic low-carbon hydrogen production and deployment? Does anyone want to go first?
Well, I should only really answer half of that question, because I shouldn't be telling recommendation to financiers should be just get on and do it. But to policymakers, I think it's the same as most bankers will say for any sort of policy. It needs to be transparent, it needs to be clear, and it needs to be stable. And I think that's the most important thing for this.
Quotas. We have a discussion about a lot of carrots here, and it's good. We need to subsidize this, but we also need the sticks. And the sticks can take the form of bans or forbidding certain technologies, but probably the best solution now is to use a green hydrogen quota for industrial applications. Yesterday, the EU seems to have finalized its target of 42% in the industrial sector. We need these quotas to be everywhere. We need to make a certainty for the green hydrogen market, so that the biggest issue of hydrogen, for green hydrogen, that maybe is cost, but really is the fact that there is no demand, no real offtake agreement. We need them to happen. So quotas, it's a good way to start having them.
I have 3 short points. Number 1, get independent science-based advice. Number 2, do the math. And number 3, think of long-term value creation.
I don't think there's much I can add to that, but I really love the 3 points that you brought up, Peter. Science-based advocacy, and I think that's what we're all trying to do on this panel over here, and not. Because at the end of the day, there are a lot of players, there are a lot of commercial interests in using hydrogen. Let's keep in context why we're looking at low carbon hydrogen. It's because we're trying to decarbonize. And there are many applications out there that can use hydrogen, new applications, but don't really decarbonize. But they're getting, in certain instances, a lot of funding. And that shouldn't be the case. We're not doing hydrogen for the sake of hydrogen. It's in vogue, yes. But one of the reasons it came to prominence is because we're trying to reduce emissions. Sometimes we tend to forget that in the grand scheme of things, among the excitement and the funding and the quotas, we're trying to do that to reduce emissions. I know it sounds very basic, but for some projects, when you do the science, when you do the math, and you take a look at how much carbon am I abating? What is the cost, carbon abatement cost? Some projects, which maybe I should name some of them. You take a look at carbon abatement costs over $1,000 per ton. Over $1,000 per ton, public money. Is that really, if it's a private developer, private money, it's a free market. But once you start tapping into the public purse, there needs to be some sort of rationale, and one of them, science, could take a look at what is the carbon abatement cost where I'm using this hydrogen. If it's above $1,000 per ton of CO2, you probably need to be looking somewhere else.
Thank you. We have some time for questions from the audience, so do get thinking. I'm going to ask one more question to allow you some time, and that is about standards and certification. Given that we've just had this publication from the International Organization for Standardization at the COP. What standards and frameworks do you think are needed to ensure that low carbon hydrogen is truly low carbon and it's going to enable decarbonisation?
So I think hopefully sooner rather than later we'll move away from the rainbow of hydrogen, and we'll start just talking about hydrogen in terms of the carbon content. And I think when we start looking at industrial policy and the stick bit in particular, and on the carrot side too as well, I should add, the real way to measure this is how much carbon was associated with the production of that hydrogen, or with that sort of hydrogen value-added product, whether it's green steel or something like that. So for me, I think this is a really important step, and that again will lend itself more to this sort of science-based, sort of mathematical, numbers-driven approach as well.
Well, in IRENA, together with the IEA, we assessed the current standard world, and we identified one issue that was also the IPHC agreed with us, is the fact that unfortunately it's not a really interesting topic. Not many people work on standards. Not many governments are willing to invest in standards for me, or creating a standardization body. Not a body. A fund to support the people working on standards, because it's not really something shiny. It's not. It's actually quite a boring activity. And but we need these people to be everywhere in the world. We can't have all the standardization knowledge in Europe. We need the standardization knowledge everywhere in the world. Otherwise, there would be no hydrogen project, because no one can then ensure that yes, this hydrogen project is actually decarbonized. So we wrote, IEA and IRENA and the UN high-level champions, we wrote a recommendation to support with finance and with human capital standardization bodies.
We haven't done a lot of work on the standards part itself, but we work a lot with innovators, laboratories, researchers. And just when it came to electrolyzers, hydrogen production, hydrogen processing, and so forth, transport, just the sort of uncertainties or the potential, say, friendly fire effects they can have from a net climate effect in terms of leakage, in terms of all other kinds of things, really ask for, again, reaffirming we should only use it if we have to. I mean, wherever we don't need to use hydrogen, we should use something else. Plus, the long-term integrity of the process is certainly something that needs to move closer into the focus.
Okay, thank you. So I'm going to turn to the audience. If you can just say who you are and where you're from when you ask, that would be great. I think you were first.
Hi, I'm Pete Budden with the Natural Resources Defence Council. Great to hear you all discuss this topic, especially the standards. Quick plug, in 10 minutes time upstairs there's a panel on hydrogen production standards in the Bologna Pavilion. Encourage you all to join. One question I have about the ISO standard that was launched. There's a few shortcomings, we think, in the methodology that we are hoping in the next iteration, and as that draft specification gets developed into a standard, will be addressed. One of them is the accounting of renewable electricity. In Europe, we've seen the adoption of additionality, hourly matching, and deliverability as key criteria. And ISO doesn't call out these in particular. Do you think there's scope for harmonization on those rules and across the globe, or is there further challenges across geographies to adopting those pillars? Thanks.
It's quite an hard question. But we have to remember one thing. There is a difference between standardization and certification. Certification is something that governments want to ensure that their money are going to go where hydrogen meets certain technological effect. Standardization can't go in that direction. It can only assume something that is happening from gate to gate, from a point A to point B. So I wouldn't be too pessimistic, even if it doesn't have additionality requirements, the current standard, because that's something that governments will implement. In addition, and just to be a bit optimistic, if power generation is continuing to be more and more decarbonized, the need for additionality will decrease over time, unless you will see a real matching of coal marginal plants when the electrolyzers is turned on. We may have actually a power sector that is decarbonized enough to ensure a limited impact of green hydrogen production, electrolytic production. Of course, this is a bit optimistic. There are studies in this direction with a simple PPA may solve the overall additionality issue, but yes, we need to prove it.
Well, thanks. Just by the way, I love your sockets. Really, really nice. I still saw some nice sockets here, but okay, I'm done. Okay, and I'm from France, from Voices of Nuclear. It's an NGO, and we published recently a scenario for energy transition in France. We included just a bit of hydrogen, because we also think I was really happy to hear that it's a hype, and we see a lot of like greenwashing about it. And so my question will be quite simple: how do you see nuclear? Is there a space for nuclear energy in hydrogen life cycle? Thanks.
So I think pink hydrogen is probably a waste of nuclear, frankly. I think nuclear's ability to deliver utility scale electricity is its greatest advantage. You look at the UAE, for example. Thankfully, there is no talk about Baraka suddenly powering hydrogen plants, because they're using that as a tool to decarbonize the electricity supply, which means that then there is the potential to, if you need to build a solar plant to power your hydrogen plant, you can do that. You don't need to sort of go, well, I need to put more solar capacity into the grid. And I think what Emanuele was just saying about sort of hopefully we see a point where the power supply is decarbonized enough that it means you don't have the same concerns around additionality of the renewables for hydrogen production. So it gets in. Nuclear could have an involvement, but it's sort of an indirect involvement. I think trying to do sort of pink hydrogen is probably not the best way to go, in my view.
Yeah, and if we have additionality requirement with nuclear capacity, we need to have a new reactor to work for the new electrolyzers. I mean, an electrolyzer takes quite a bit of time to be delivered, but less time than, the power generation can be delivered in less time. With the nuclear energy taking quite a bit of time to be delivered, it's not really a realistic assumption at the moment.
My turn. I am Cesar Daoudi from the Swedish Energy Agency. Thank you for mentioning the green steel in Sweden. They want to be close even to Volvo and Scania steel makers. I liked very much the 3 points you made. The independent science-based evidence, and do the math, and also the value creation. I would like to ask a question. Does anyone have done the math of the cost of transporting hydrogen as ammonia, not for using it as ammonia? That I agree totally is wise, but to crack the ammonia and get hydrogen out of it, with all costs, with catalytic systems, with after-treatment systems for long term. For me, it's really, I don't understand why so many people talking about transporting ammonia long distances. Maybe at the end of the day, it's cheaper to have pipelines. I don't know. I'm just... Yeah.
Yes, sorry.
No, I mean, these guys have done a brilliant study on this, and I have the same effect. It's puzzling me all the time when I see these MOUs and so. But I would like to give it to Gus, because they have this great study.
Yes, I guess Peter's puzzled. I'm puzzled. I think everybody else in the world is puzzled. You have ammonia crackers or projects for ammonia cracking, even in Germany, going up in Germany. And the long story is, that if you want costs to be reasonable, delivered costs to be reasonable, that should, destroying ammonia. I mean, we struggle to produce enough ammonia to kind of feed the world in terms of fertilizer. To have that ammonia and then break it back, that's just energetic vandalism. It's thermodynamic suicide, right? To do that, and not only that, CATF published a study a few weeks ago on the realities of hydrogen export, and we took a look at ammonia, liquid organic hydrogen, liquid hydrogen. Just because ammonia is the least bad of all three options, so to speak, does not make it an attractive option. It's not an attractive option, and especially when you consider ammonia cracking. In the best case scenario, using green hydrogen from, producing ammonia at $600 per ton, transporting it, cracking it. In terms of the calorific value cost, it's, again, best case scenario, we're talking 15, 20 years from now, 100 euros per megawatt hour in terms of the calorific cost. That's 4 times the average cost of, let's say, natural gas in Europe, 25 euros. And, we're seeing what's happening to heavy industry in Europe today at 50 euros. So imagine twice that. But again, it's more philosophical, and we're still considering that even if you transport it in ammonia, the life cycle emissions of the delivered hydrogen are 0. So we're decarbonizing. In fact, if you take a look at production, because not every place is going to be like Neom, where you have the amazing renewable profile, right? You're going to have some carbon footprint on production. The ships that transporting the ammonia, they're not going to be running on ammonia tomorrow. It's going to be diesel, fuel oil. And when you get to the cracking, yes, some manufacturers or most of them say that they're going to be using the ammonia or the hydrogen to power the cracking process, right? But in fact, even with that, you're going to still need some electricity from the grid that's running 24/7. There might be some tail gas, maybe some natural gas. By the end of the day, you're getting extremely expensive hydrogen. You're destroying ammonia. And you're not even, the carbon intensity of the delivered hydrogen is not 0. It's probably maybe 50, 60% better compared to unabated natural gas, right? So again, it begs the question, does it make sense in the context of decarbonizing or reducing emissions? And the clear answer to that is no. Yes.
You have a paper, right?
Yes,
I would love to read it.
We'll share it with you. Yes,
yeah, thank you.
Sure.
I think we've got time for 2 more questions, just these 2 over here, and then we'll wrap up.
So it's actually a follow-up on ammonia, but ammonia is the largest user of hydrogen right now, and demand for ammonia is most likely going to increase if we think about the context of Africa. And so I was wondering what your thoughts are about the role of ammonia in enabling, in general, like low carbon hydrogen.
I can answer you also considering our scenarios for the energy transition. Yes, around 40% of the hydrogen today goes into ammonia and 85% of the ammonia goes into fertilizers. And that's the opportunity. It was mentioned steel as another great option. I would like to add fertilizers among them. And they are a great opportunity for developing countries for actually using hydrogen in a smart way. Imported fertilizers are the main driver for food costs in the global south. The natural gas price crisis made food double the cost in Kenya, in Ethiopia, and in all the South African region. We need, this is the opportunity that actually exists. Ammonia will not be transported to be cracked. Ammonia may be transported for local usages to do fertilizers elsewhere, but that's the case.
I think we've got time for one more. Sorry, we can. We'll have to follow up. I think after.
Real quick, the applications that you mentioned where hydrogen is possible or likely, it seemed to be boiled down to electric power generation. I think maybe I got that wrong, but my question was more along the lines of shipping, especially in the Arctic, where currently there's a lot of heavy residual oil or whatever that is being used, and there's a push to make them use distillate, which even that is not happening. Maybe it will, but seems like that, and that leads to a lot of emissions of black carbon on the Arctic ice, leads to faster melting of the ice, and that's a tipping point, right? I have a session on this tomorrow here. But basically, is hydrogen a possible use case for, possibility for shipping, especially in the Arctic, when you want to control emissions in that critical zone?
Thank you. Yeah, sorry. The no regret application I mentioned on steel was just quoting somebody on the marginal value of every additional green electricity megawatt hour, kilowatt hour, however you take it. There's a number of applications. Of course, there's the existing hydrogen demand of black hydrogen, and then for decarbonizing, like ocean transport, shipping, maritime, aviation, we will need low carbon hydrogen, no doubt about it, to create synfuels, to create sustainable aviation fuels and so forth. Yes, there are a number of future applications, but I was mentioning more the ground transport applications where it certainly doesn't make sense.
Did you have a final question?
Just a comment.
Okay.
So, for those interested in ammonia, there's a small company called Talis Renewables that just announced a distributed green ammonia production project. They launched the first in Kenya last week. And they are slowly rolling out additional projects in other countries. And I think that's one of the big factors that you all talked about is the carbon footprint of the transportation. But if you remove that variable from ammonia production, right, and you're doing it distributed scale with, say, behind-the-meter renewables, totally changes the cost profile and the carbon profile of the ammonia produced. So for those interested, you should take a look.
Great. I think that's all we've got time for. So thank you so much for coming, and thanks to the panelists. I think we've covered a whole range of different issues. So it's been a really fascinating discussion. So thank you all very much.